Hi, welcome to our channel Math and Math. So today we will be solving a CSIR net problem on matrix. So this is a part B question, therefore only one option is correct. So what is given? Let A be a 3 cross 3 matrix with real entries such that determinant of A is equal to 6 and trace of A is 0. If determinant of A plus I is equal to 0, where I denotes the 3 cross 3 identity matrix, then the eigenvalues of A are. So four options are given. We need to find the eigenvalues of A. Given the clues, determinant of A is 6, trace of A is 0 and determinant of A plus I is equal to 0. Okay, so here instead of solving it, we will try to eliminate few options so that we get the correct option quickly, because we don't know what is the matrix A. Therefore, using these clues, we will try to eliminate few options and try to get the solution. Okay, so first of all, to find out the solution, we must know the relationship between the determinant and the eigenvalues. So therefore, determinant of the matrix A or determinant of any matrix can be obtained by the eigenvalues, that is product of the eigenvalues gives the determinant of the matrix. So product of the eigenvalues of A gives the determinant of A. So therefore, here in our question, we have determinant of A to be 6. So here we have eigenvalues. Let us multiply and check which of the following options gives the determinant as 6. Okay, so which options gives the determinant to be 6, we will check. So option 1, minus 1 into 2 into 3, we get minus 6. So option A is not correct. So we get here minus 6. So option A is not correct. What about option B? 2 into minus 1 into minus 3. Yes, we get 6. So this is equal to 6. But we can't say that option B is correct because it has to satisfy other two conditions, that is trace of A and also determinant of A plus I. So let us go with the next option. 1 into 2 into minus 3, minus 6. So here you're getting minus 6. So option C is not the correct one. Option D, 3 into minus 2 into minus 1. Yes, it gives 6. So therefore, either option B or option D may be the correct one. So we eliminated two options, options A and option C. So therefore, either option B or option D satisfies determinant A to be 6. Now let us check for the next condition, which is trace of A is 0. So trace of A is equal to 0. So now how do you relate the trace and the eigenvalues? So trace is sum of the diagonal entries. So trace is sum of the diagonal entries. So if the eigenvalues are real and distinct, then trace of A will also be equal to sum of the eigenvalues, will be equal to the sum of the eigenvalues. So let's check for option B. When you add option B, the eigenvalues of option B, minus 3 minus 1, which is minus 4 plus 2, it gives minus 2. So therefore option B gives minus 2. What about option D? Option D, when you add the eigenvalues of option D, that is minus 1 minus 2 minus 3 plus 3, it gives 0. So therefore trace of A is equal to 0 for option D. So therefore determinant of A is equal to 6 is given by option D and also trace of A is given by option D. So we will also check for the last condition, which is determinant of A plus I is equal to 0. Determinant of A plus I is equal to 0. This condition also has to be satisfied by option D. So determinant of A plus I, that will be given by the eigenvalues of A when added by 1. So eigenvalues of A which we determined was -1, -2 and 3. These are the eigenvalues of A. So to each of these eigenvalues we must add 1, that is the identity matrix. So what do we get? We get 0, -2 plus 1 -1, 3 plus 1 which is 4. So what is the determinant of A plus I? That is product of the eigenvalues of A plus I. 0 into -1 into 4 which gives 0. So therefore determinant of A plus I is equal to 0. This is also satisfied by option D. So option D is the correct solution. You must remember one point, that is, if the eigenvalues are real and distinct, then it satisfies the properties, that is, if the eigenvalues are real and distinct, it lies in the main diagonal. It doesn't mean that always the eigenvalues will be in the diagonal entries. Okay, so -1, -2 and 3 are the eigenvalues which is lying in the diagonal. Since they are real and distinct, this lies in the diagonal. So therefore when you are taking the product of the eigenvalues, you get the determinant of A, and when you are summing the eigenvalues, that is in the diagonal, you get the trace of A. Also when you are adding the matrix A with I, you get so this is the matrix A and this is the matrix I. We are not bothered about other elements of the matrix A. We need only the diagonal entries of the matrix A. And here in the identity matrix also we are concerned only about the diagonal entries. So therefore when you add A plus I, we get 0, -1 and 4. So therefore they are also real and distinct. Therefore these itself are considered to be the eigenvalues. So when you are finding the determinant of A plus I, that is given by the product of the eigenvalues of A plus I. Product of the eigenvalues of A plus I. So this is equal to 0 into -1 into 4, which is equal to 0. So therefore determinant of A plus I will be 0. Okay. So by viewing at the options, we can make out that option D is the correct answer. Option D is the correct one. Okay. So just look on to the eigenvalues and check for the product of the eigenvalues. If it gives the determinant of A to be 6, then check for the next condition trace, that is sum of the eigenvalues. If you get 0, then that is satisfied. Again find out the determinant of A plus I, that is to the eigenvalues of A add 1, then multiply them so that you get the determinant of A plus I. If it is 0, then that particular option satisfies all the condition, therefore that is the correct solution. So therefore here option D is the correct solution. Thank you.